Welcome back for our final plenary session of Pycon 2017. The candle has burned low, but there is still a flame left. What was initially measured in days, then in hours, now is best measured in the minutes we have left together. I am very happy, very excited to announce our closing keynote speaker. Please help me with a big hand to welcome to the stage Mr. Kelsey Hightower.
Hello. So this is really an honor for me because my very first speaking opportunity was in Atlanta at Georgia Tech, and I went to go see what smart people do when they get off work. And apparently they go and they continue talking about technology at meetups. And I was learning Python at the time, and this is when you went to the bookstore. For some of the younger people here, there's this place you go and you buy these things, they're called books. And the bigger the book, the more knowledge in there. So all the Python books are like 10 pounds. And I bought one of these books, and I was like, I'm going to learn Python, and I'm going to go to a meetup because that's what smart people do. And I'm sitting there, as you guys are sitting here, and I'm watching the speakers like, I can totally do that. So I emailed the organizer. There's this guy named Brandon Rhodes. I was like, I want to give a talk. Well, have you spoken before? Nope. But I can totally do it. Like, you just do a lightning talk or something. So to be smart, the first topic I picked was comparing Python list comprehensions with Haskell list comprehensions. And no one knows Haskell. So if I show up, I'm just going to be the smartest person there. It's like, you've never seen this. So when Brandon reached out again and said, hey, Kelsey, I want you to come speak at this event that I'm running. I was like, well, how big is the meetup? And I get here, I'm like, damn, this is a big meetup. So for a lot of you, meetups do change or can change your life. The Python community has changed my life. My very first conference was Pycon in Atlanta. And it ruins you because, trust me, you guys should clap for that. The thing about Pycon that's amazing is really the community. A lot of people here I actually heard pay their own way to be here. The number of people that stick around for the sprints are amazing. So my first contributions to Python were pip, virtual inf, and dishutils. And since then, I've grown on, and the world of technology, oh yes, those are fantastic things. So last night, I wanted to write some Python to remind myself of why I fell in love with the language. After about 3 or 4 hours, I tried to deploy the thing that I wrote and find out the things I didn't like about Python. So we're going to talk about Kubernetes for Pythonistas. And the root of this talk, I'm not going to try to dazzle you with all of the things that Kubernetes can do, but I want to educate you a little bit on what containers are and why they're important to people, especially in Python. Many of these languages have very complex dependency systems, and they could be a barrier to entry, especially if you're building or distributing software. So we're going to go through this and think about this from the very beginning of how you would think about containers helping you, okay? Now, I heard this was a technical conference, so this is my last slide, if that's okay. Let me know. I can find lots of cat pictures on the internet. So we're going to be in this mode for a while, okay? So when I first started learning programming, I was about 24 years old, and I had that book. And I wrote my first Hello World program, kind of like this one. And Python is like magic. You write a few lines, and you really believe you're a real developer. I started applying for jobs immediately after this was done. Senior developer, Python, 5 minutes of experience. And you look at this code and you're like, wow, this is pretty awesome. So I'm going to run it. You always automatically should know what this does. So we'll say Python, and then we'll say our app py. Okay? This is sweet. And then you go to your browser. And this is where your life changes for the first time. If you're new, when you see this is when you run around your house, and your spouse is like, what are you doing? That is not impressive. Like, that's hello world. Like, I could do that on a piece of paper. But it's important, okay? Now, I got brave. My first Unix machine, FreeBSD. Right? FreeBSD people are serious. They have, like, tattoos of the mascot. I'm like, that's not ever coming off, right? So we got this hello world thing going. So I was like, you know what I'm going to do? I'm going to run it on my server. This should be easy. I got this one file, this app py. So you copy it to the server, and it's tiny. And then you go to type Python, and nothing's there. And then you become a sysadmin. In FreeBSD, you do not install Python the easy way. You have to heat your whole house from the server. You compile from scratch. This is what you do. So after about 6 months, I got Python on my machine, and the app didn't run. And then I needed pip. 2 years later, my app was running. It wasn't that bad. But this is what we're asking people to do when we write code. We're asking them to go and figure out what version of Python they have, what version of the dependencies they have. God forbid if you're using some C extension. And trying to use that on a Chromebook is very funny seeing that in an airport. It's like your computer's going to run out of battery in about 30 seconds. So we have all these dependencies, and packaging has come a long way in Python, right? So we have this ability now to say, hey, here's what my app requires. And I can just do pip install. And I just did a little tweet. I'm going to show you guys what it looked like. So I'm on my Mac, and I'm writing this test app for the demo. And I do sudo pip install dash. You guys are already like, what the hell are you doing? So I'm like, yeah, what could go wrong? I have Python pre-built on my machine. They're like, dude, the first rule of Python is you don't use system Python. I'm like, hold my keyboard, enter. You type in your password, right? And then it's like, your InfoSec team is like, what the hell are you doing? Nothing works anymore, but I have Flask and everything I need on my machine. So we're winning. Like, I had to do this. So we have our app now, and we start to ask ourselves that there has to be a better way of doing this. So when I used to contribute to Python, I told you we had disutils, and there used to be a war, setup tools, disutils. And then we made peace, and the whole goal was not to reinvent the wheel. Let's improve what we have. So last night I was like, what is the state of the art in Python? And it turns out we literally reinvented the wheel. I thought this was a joke. I was like, no. It's not actually called wheels. They're like, no, man, this is what you do. And I was like, okay, wheels it is. So the truth is, packaging is a pain point for all languages. It's a pain point for all software. Things that work well are like your mobile device. You go to an app store, you bring the whole package down. And the reason why we can have 1 billion devices is because we do not ask users to go and install other software to use the software that they're interested in. As simple as that. But we do the opposite when it comes to servers. We're making everyone's life difficult. Anyone have ever heard of DevOps? Anyone know what DevOps is? I took a stab at it. DevOps is group therapy for sysadmins. And we needed it largely because of packaging. It's not just Python. All those packages need to be maintained. They need to be updated. You write a Python app and say, hey, install this, and all the sysadmins just leave. So how do we make this better? And this is where I think containers become interesting. How many people think static linking is a good idea? How many people like containers? It's amazing to me that so few people think static linking is a good idea, but they like containers. This is static linking on steroids. It's a big tarball with everything. A full operating system is in there. You're linking everything. I saw one container, it had like a Chrome browser in it. I'm like, what are you doing? So what we want to do is, how can we leverage these containers in a very smart way? So just so everyone's on the same page, a container, there's two parts to this. There's a packaging format. The goal is we package all of our dependencies into a tarball. It is actually a tarball. And it's a tarball with a specific format so we know how to download it, extract it, and be very efficient with layers. So what we're going to do is build one of these things. Now, I've cached most of this because these days, no matter what app you build, for some reason, it downloads like 2/3 of the internet in order to work. But I'll show you what one of these looks like. So we have our application. So what we're going to do is start with this Docker file. So the Docker file here is, you'll see the first line there. It says from Ubuntu. Yes, that is an entire operating system to put our 2K application into. Now, there's a reason for this. How many people here would say they honestly know all their software dependencies? Exactly. So when you don't know, you just bring in everything until it works. And then we get DevOps. So the next thing I do here is, there's a couple of things happening, though. We take all the tribal knowledge from wikis and runbooks, and we put them in the Docker file. Now, this is not the best we can do, but it is a good stepping stone for the majority of the people building software. And we can do clever things like cache some of the layers. So even though that first layer is pretty big, it's actually only about 70 so megs, we can cache that on the servers, so we only have to copy it once for our apps. Okay? So the next thing we're going to do here is going to do apt-get install Python 3. Everyone's using Python 3 by now. Please tell me it happened. All right, just clap in case, just pretend. And then we copy our requirements.txt into place. Now, the goal with this whole thing is that now everyone has a very sane and clean build environment, and they can build their application. You can either give people the raw Docker file, and they can build it themselves, or you can build it and store the artifact. Right? So if you've ever built any package of any kind, the goal here is to build an artifact, and we'll store it somewhere. Now, once we have the artifact, we can give someone the image name, and they can run it. So we'll just build this here so we can see what we're talking about. Now, my Python is rusty. So if you see any bad code today, please give me a pass. Do not put it on Twitter. I promise to follow Pep8 later. OK, so we have this entry point. So this is basically going to do the same thing I was doing on my command line, and we're just going to set that in the entry point. All right? So we're going to make a tarball now. This is a very fancy way of doing it. So we'll just do this docker build command. So here what I'm doing is saying, hey, I want to build this image, and I want to run that command. But what I want to do is have all of the requirements be pulled down and run inside of a chroot environment so that I have a clean build that's reproducible. So we'll run this now. OK? So the lucky thing is here is that I'm having a bit of caching. So I didn't change any of the lines at the top. Now, you could run into issues with some of this caching, but the nice thing is when you're building and writing applications and you want to iterate fast, you do not need to run the whole entire apt-get command or the pip command again. Those live as separate layers. So once you have that, we can just copy in our application, and then we can run it. How many people think it's really easy to run multiple copies of an app on your machine? Not a lot of hands. How many people are using virtual env to solve this problem? OK, So if you're familiar with virtual env to give us multiple Python environments, you can look at this runtime. So this is the other part of the equation. Once we have this tarball, we can run it under a runtime. So let's do this really quick. So we'll say docker run. All right, so what we're going to do here is we're just going to run our app to make it a little bit easier. So we'll just run it on 5,000 to 5,000. So I'm just doing a bit of port mapping so I can get to it. We're going to run this Hello World app, and it's going to run in the background. So at this point, I should be able to hit it in my browser. And there it is. Now, I can run as many copies of this as I want, maybe map to different ports. But this only solves the laptop problem. We have this thing packaged. It's easy to distribute. It's easy to run as many copies as I want. But what happens if I have 5 or 20 servers that I need to push this to? How many people are familiar with scheduling? Every hand should be up. Every device that you have has probably more than one CPU core. And when you launch an application, there's a kernel that has to figure out where this thing runs. So you have a really effective scheduler there. What most people are doing these days in lieu of a scheduler, we call it like the meat cloud, okay? This is where you say, hey, run this application, and a human decides where it runs. And sometimes we track in a very fancy database, AKA spreadsheet. And the problem with this is if one of the machines dies, they have this thing called on-call, okay? Machine goes down, you get a call, and you get to put the app back on the machine. So what we want to do is like solve this problem in a way that goes a little bit further than our laptop. So we have a tool called Kubernetes. Now, there's other tools that do very similar things, but we're going to work with this for now. So I have about 5 nodes in my cluster. Now, the goal with this is that I do not want to statically assign my apps to machines. They're designed to go away. I want to treat each machine as one collective or like a multi-CPU system and treat the whole cluster like a single machine. So we need a new API. We need some abstractions. So once I have this abstraction, we can package our container in what we call a deployment. So let's look at this really quick. So we have this deployment object. So here is the container we've built, and we have it hosted somewhere. So anyone that wants to run this app can pull this particular container image. Now, some of you are like, well, how does the system know where to put this? Since a lot of people didn't raise their hands about what a scheduler is, I'm going to explain it. Now, the fastest way I've done this without diving too deep into computer science and hijacking my whole talk, we play a game of Tetris. So, how many people here say they have fully automated deployments? Okay, now this is a worthy goal to get to. You click a button, and your app installs to specific machines. I'm going to show you what that looks like. You do that in Tetris. I'll show you what it looks like. It's amazing, by the way, if you can get to this point. So the goal is we want one-click deployments of all of our apps. Now, you need to know a whole bunch of information ahead of time in order for this to work. You need to know all error scenarios. You need to know if a machine is in maintenance or not. And you need to make sure there's no network issues because you need to be able to route around them, all in Bash. Python if you're lucky. So what we're going to do is, this is one-click deploy. This is the DevOps holy grail I'm about to show you. Be ready. You ready? One-click deployment. Bam. One click. And then you leave. It's fully automated, by the way. But the problem here is your memory and CPU is just on the floor, and you're losing. Now, I work at a cloud provider. This is pretty good, actually. Spin up more VMs. So what does the scheduler do? So here's the difference. The scheduler has to actually examine every workload as it comes in. Now, this is the x86 architecture. You're not doing anything that fancy. But things are slightly different, so they have different shapes and sizes. The goal is we look at these workloads as they come in, and then we make a decision. So what Kubernetes does out of the box is what we call bin packing. So let's look at what that looks like. So here, we see a workload, and the goal is just to place it by examining it. Now, we look at these workloads as they come in, and what we're doing now is just scheduling in a way that we try to utilize all of our resources. So this is memory and CPU. I'm looking at all of these workloads coming in. Now, half of you are like, wow, this dude is really good at Tetris if he can totally talk and play Tetris at the same time. okay? But this is still bin packing that's happening here. Now you'll ask, why is the scheduler doing this? Well, when we examine all the pieces here, what we want to do is make sure that we allocate things in a way that, imagine a machine learning job comes that needs that CPU, and you've been reserving that special machine because it costs a lot more to run things on it, and when the right workload shows up, you can place it there. And then when it's done, you get back all the CPU and memory. He got a Tetris on Twitter. So that's kind of the difference between just automation and this idea of orchestration. We want to have this online examination of every workload so we can actually use our machines effectively. And the goal here is that we want to be able to reuse CPU and memory the best way we can. So it's part orchestration. So how do we do that for our own applications? So for our own apps, we have to make this deployment descriptor. Now, it's a big YAML file, and it's declarative. But what you'll see here is that we have our app name. It's called Hello World. And then we're saying, Kubernetes, when you run this thing, I want you to go grab this particular image. And when you grab that image, I want you to extract it and run whatever the entry point was, Python, app py. And then I want you to also shape this workload. Now, the thing you got to think about, in order for us to schedule these things properly, we need to know the shape of the piece. This is why we have our memory and our CPU requests, so we know where it fits in the cluster, okay? So once we have this, we can actually give it to Kubernetes. So kubectl get pods. So what we'll do is we'll create this deployment object. Now, can anyone tell me what machine that it landed on? There's a brave guy like, number 4. Like, no. The scheduler is going to figure out at runtime. The only thing we are asking is that we declare that we want one of these things running. So if I say kubectl get pods, we'll see that it's running somewhere. Now, the nice thing about this, let's look at what machine it's on. So it's on NF6P. And it has its own IP address, .90. But what happens if we were to destroy it? All right, we're going to destroy the workload. Now, depending on where you work, you're either fired or you're going to get a call. So we delete the workload, and this is what we expect. We expect it to be replaced quickly, and it has a new IP. And the nice thing about a system like this is when we replace the workload, we keep track of it. We know its IP address, so we can hook it up to the load balancer automatically. Now, if you've been doing this kind of work, this is just from decades of people doing these patterns, and now we've just baked it into the infrastructure itself. It's kind of like the Python standard library. It's massive because there's no reason for people to rewrite these things over and over again. So these are things of pretty standard issue. If I look here, get SVC, we'll see that we have a load balancer that's routing traffic to all of those. So no matter what I do, I have this stable endpoint where I can hit my application. And there we go. It's up and running. Then it gets really complex. You're just like, you can't run production Python by just using Flask. Anyone know why? One request at a time. I spent the hour figuring that out. It's like, why is my shell hanging? One request at a time. So what do? So in the Python world, it's common to pair it with maybe some WSGI server or Nginx. So what does that look like in Kubernetes? Now I'm about to show you a lot more on the screen, so be prepared. So in the container world, one would say you build an even bigger Docker file. And you install Nginx in there, you put your WSGI in there, and then you take a script to launch all of that in the background. Great. You just invented an init system. There's no reason to do that. What's a better approach? Well, we don't want to pack Nginx inside of our apps container. We want those to be separate. So what does that look like if you separate them? So here's another deployment object. And this time, we'll do things, and this is a lot here. I'm going to walk us through it really quick so we all can understand. This has multiple containers in them that we can stack. Think of it like a virtual machine. They're just going to run as processes that are co-located together. to form the logical app. So at the top, we have Nginx. We're using Nginx graceful shutdown. And then what we also are telling Nginx to do, you'll notice here in this particular line. Here, we're going to share this particular path. And what's going to be there is going to be our WSGI Unix socket that is exported from our app, so we can actually send traffic to it in the way proposed by their particular docs. So here, we are sharing a file system. One container is going to write its socket there, and another container is going to pick it up and send traffic to it. But the nice thing about this is everyone knows how your infrastructure is composed. Nginx stands alone, and the app stands alone. So at this point, we can actually have Kubernetes manage this for us as well. kubectl create-f deployments. All right, so once this is online, get pods. Great. And you'll see that there's 2 of 2 ready. So we can actually compose these things. If you need any helpers, you can run your helper scripts as well. Now, once you have infrastructure like this, you start to think about, why do I need to use conventional ways of interacting with it? I've been using command line tools this whole time. So in the Python world, one thing that has been amazing over time in Python, Python has been used as a facade for more complex systems like TensorFlow, most big data stacks. Python makes it super easy to interact with things. So if I were building new tools, how would I interact with this? Now, I think if more Python people showed up to the Kubernetes community, they would also look to simplify things. So I found a really good Python library. So I wrote a new interface to Python. And this is the first time I'm going to show it to anybody. OK? So if it doesn't work, remember, I wrote this yesterday. So bear with me, OK? So what we're going to do is we're going to clean up here a little bit. Get pods, kubectl. We're just going to delete these deployments. So it's really easy to spin these things up and down. Let's clear them out. And keep in mind the frame of reference I'm coming from. I've been watching Star Trek: The Next Generation for some reason on Netflix. So I really believe I'm living in the future right now. So when I went to go build this thing, I wanted something that felt like that. OK? So let's just do a watch on here. I'm going to show you my new tool. As you can tell, I'm a bit shy here. So please don't laugh at me if this doesn't work. All right, so this should terminate. Let's clean things up. Man, do you know what it's doing? It's trying to gracefully shut down. All right, we're down. OK, so we're going to try this thing. So and the app I'm using was shipped on Wednesday. So this is just double not smart. On conference Wi-Fi. OK, Google, talk to Kubernetes. Hold on. We may have to go to airplane mode because I might need the bandwidth, OK? OK, Google, you better work because people are watching. I spent all night on this too, so talk to Kubernetes. No way. Hold on. We're not going to abandon ship on this. I will be up here for 6 hours if I have to. You just ignore the whole speaker timer. OK, Google, talk to Kubernetes. What? It's sitting here like, ha ha. I got it. Let's do this. Maybe we have to hit the test button. Maybe we need that. Don't you guys like when the live demo doesn't go well? You're like, he's going to fail, I know it.
My apologies. I don't understand.
Talk to Kubernetes.
This is the top result.
Talk to Kubernetes.
Here's the top search result.
It's trolling me. OK, Google, talk to Kubernetes.
Sure, here is the test version of Kubernetes cluster.
Hello, Kelsey.
Hi.
Looks like you have a large crowd this time. I hope the demo gods are on your side.
What's my cluster status?
The Pycon cluster is running with 10 CPUs and 37.5 gigs of RAM.
Run the Hello World application.
What image tag would you like to deploy?
1.0.
Deploying Hello World 1.0 into the Pycon cluster.
So we got an app running. Scale the Hello World deployment.
How many replicas would you like?
500 divided by like 10 minus 40 minus 5, 5. 5.
Scaling the Hello World deployment to 5.
Now, here's the thing. It's easy to do deployments. How many people have ever done 0 downtime deployments? You liars. You still got on call. But no, it's a tough thing to do. So the holy grail is to do these downtime, 0 downtime deployments. So we have 1.0 running right now inside of our cluster. And the goal is we want to upgrade this. So this is the nice thing about this fully API-driven world, from the networking to the storage to the app itself, also around auto-scaling. So what we want to do here is see if we could update this in place without dropping any of the packets here. Okay? Update the Hello World deployment.
What version of the application would you like to deploy?
2.0.
Updating the Hello World deployment to version 2.0.
Thank you.
Okay, I gotta admit that was pretty dope.
And with that, I would like to end the presentation. Thank you so much.
Okay, I gotta admit that was pretty dope.
Another round of applause for Kelsey Hightower.